So we see that the electric field is a way of visualizing the force that a charge would experience if it's brought near another charge. In other words, it's kind of giving you an idea of how space around that charge is affected. I want to look a little closer at that. If you remember from an earlier video, we basically put a small, what they call a test charge, nearby our original charge. And we ask ourselves, what direction would the force be on that charge in that location? It's not hard to imagine that it would repel. So it'd be something like that. And basically we go around and we put the test charge in lots of places. And we start to see that there appears to be lines diverging from the big charge. That's the force of gravity spreading out over larger and larger areas, exceeding the force of electricity. And it shows that that force is getting weaker. So the picture is helpful for us to understand that. But we do have to remember something, and that is that I put a positive test charge there. What if I had put a negative one? Well, in that case, it would be attracted. It would be doing exactly the opposite of what the positives are doing. So it would be kind of being pulled back along this line. So it's a useful picture for helping us understand how the space is altered around a charge, but we do have to remember a rule. We always draw it as if our test charge is positive. So if you threw a positive here, it would experience force along these field lines. You just kind of have to remember if you throw a negative in there, it would experience force opposite those field lines. So how many lines did I draw? I drew 8 because I think it kind of looks nice. And it's really symmetrical. It kind of shows the pattern. But clearly I could have drawn an infinite number of them. Could have drawn one at every single location. So you pick a reasonable number. But what's important is that when you're dealing with more or less charge, the number of lines should be proportional. This charge affects space a certain amount. This one's going to affect it twice as much. So I should draw twice as many lines. So I drew 8. This time I'll draw 16. 1, 2, 3. So that's one thing to keep in mind. We can clearly see that this is affecting space more than that is. We have to remember again that our rules are that we put a positive test charge. So now that I've got this negative charge here, what direction is the force on it going to be? Inward. So when I draw the electric field lines, they're actually going to be coming inward. And that will show that positive charges will experience an inward force and the negative charges will be repelled. Notice it's exactly the opposite of what we had for positives. So we should write a general rule. For positives, field lines go outward. And for negatives, field lines go inward. Notice I have the same number of lines on this negative that I do on this positive because they represent the same amount of charge. Last topic is how do field lines interact between different particles? Well, they have to go out of the positive into the negative. In this case, they have to go out of both positives. So Best thing to do at first is to draw the correct number of lines that you've decided on coming out of your charges. So I've said a plus charge has 8 lines. So I've got 8 on both of them. It's got to be going out of this guy. It's got to be going into this guy. And all we do at that point is we start connecting the lines. So I'm going off the board there, but you can imagine it's going above the plane of the board and coming back in. So it looks kind of crazy. It looks like we've got lines going all over the place, but we could figure out that if I put, let's say, a test charge here, here it's going to experience a force away from the positive and towards the negative, and apparently along that line. Of course, a negative would have felt the opposite. Let's do the same down here with our 2 positive charges. So in this case, they all got to come out all the way around. So let's start to draw these 2. This one's going to go in this direction. This one's going to go in that direction. But here's the deal. The lines can't really cross each other because they represent the force that a particle is experiencing in a certain location. If they crossed each other, it would be like experiencing 2 forces, and that can't happen. So as these guys approach each other, they have to kind of curve away from each other and not cross. The same thing happens here. And with all these other ones, they all continue to go outward. And they have to avoid crossing each other. And we can imagine putting a positive charge here. It's going to be repelled by this charge, but also by this one. So the best route for it to go is a force in this direction. And then later on it will be pushed more vertically. One over here, same deal. It's balancing its repulsion from here with its repulsion from the other. So electric field lines, they're complex to draw. They take a little effort. Mine are not the prettiest. But there's something worth knowing because with multiple charges, it's a quick way to figure out the direction a charge is going to experience a force in.